This is a video on using differential equations to find a model for population growth. The question is, the United States population reached 100 million in 1938. In 2008, it reached 300 million. A model for the population is that the rate of change of population is proportional to the product of the population and 500 million minus the population. What will the population be in the year 2040? So the differential equation that comes with this model is that the rate of change of population is proportional to rate of change, remember, is dy over dt, when y is the population, is proportional to means equals k times, and then we write down what follows. It says it's proportional to the product of the population is y, and 500 million minus the population. To make it a little easier, I'm going to write everything in hundreds of millions. So 500 million corresponds to 5, and I get 5 minus y. Notice, by the way, 500 million is a carrying capacity. When y hits 5, then dy dt is 0, and the population stops growing. To solve this differential equation, we separate the variables and we integrate. So we divide by y times 5 minus y, and we multiply by dt on both sides. And we get the integral of dy over 5 minus y equals the integral of k dt. To solve the integral on the left, we need a little algebraic fact that we'll get to in a week or two. Right now, just trust me, that 1 over y times 5 minus y is the same as 1/5 times 1 over y plus 1 over 5 minus y. This is called partial fractions. You can verify it if you want by adding these fractions. So we integrate all three of these. The integral of dy over y is a natural log of y. Notice y is positive, so we can drop the absolute values. The integral of 5 minus y, little substitution gives 5 minus y for u. Du is negative dy, and that's why I get a negative sign for the natural log, because we're going to have a 1 over u du with a negative. And the integral of k is kt plus a constant I'll call c1. Now let's do some algebra. Multiply 5 on both sides. K times 5 is still a constant. I'll call that k1. c1 times 5 is still a constant. I'll call that c2. Combine the logs using the log rule. And then exponentiate on both sides with base e. And then e to the k1t plus c2 is e to the k1t times e to the c2, and e to the c2 is just a constant, which I'll call c. Then there's a little trick that helps with the algebra, and that is to let the right-hand side, ce to the k1t, just give that a letter. Let's call that m. And we get y over 5 minus y equals m, and then we could quickly see this is just basic algebra. Multiply by the denominator, and then move the m's together, factor out the y, and divide by 1 plus m, and that solves for y. Then substitute, our m, remember, was c e to the k1t, so we know that y is equal to 5 times c e to the k1t over 1 plus c e to the k1t. So now let's get the constants. We know the population was 100 million, or 1 in hundreds of millions, in 1938, which we'll call the initial time 0. So that tells us y of 0 equals 1. In 2008, which is 70 years after 1938, it was 300 million, so that tells us y of 70 years later, is equal to 3 in hundreds of millions. So finally, we want to find out what is it in the year 2040. Well, 2040, you can do the subtraction, is 102 years after 1938. So we want y of 102. So now let's plug in. We plug in 0 for t. We plug in 1 for y. So 0 here, and a 1 here. And we get 1 equals 5c over 1 plus c. And then do the algebra. Multiply by the denominator and solve. And we get c equals 0.25. Similarly, let's plug in t equals 70 for t, and let's plug in 3 for y. And when you plug that in and multiply by the denominator, isolate the exponential, take a natural log of both sides and divide by 70, put it into a calculator, and you get K1 is about equal to 0.0256. So there's our solution to the differential equation. We have y equals 1.25 e to the 0.0256t over 1 plus 0.25 e to the 0.0256t. Now we can answer our question. We just plug in 102 in for t, and I drop that into a calculator, and what I get is 3.86. Remember, those are in hundreds of millions. So we could say the population of the United States is predicted to be approximately 386 million in the year 2040. And we finished the problem.